Blockchain is a distributed digital ledger technology that records transactions across multiple computers. It operates as a network of connected nodes, where each node maintains a copy of the entire ledger. Each block in a blockchain contains three main elements: a cryptographic hash of the previous block, transaction data, and a timestamp. These blocks are linked together using cryptographic hashes, forming a chain of blocks, hence the name blockchain. Unlike traditional databases controlled by a central authority, blockchain operates on a decentralized network of computers. This design makes blockchain transparent and resistant to modification, ensuring data integrity through cryptographic security. In summary, blockchain is a revolutionary technology that enables secure, transparent, and tamper-resistant record-keeping across distributed networks. The concept of trust is fundamental to digital systems. Traditional digital systems rely on trusted third parties like banks or government institutions to verify transactions. Users must place their trust in these centralized authorities to maintain records and verify transactions. This centralized approach creates vulnerability points where trust can be broken. Blockchain fundamentally changes this paradigm by creating a system where trust is built into the technology itself. Rather than relying on intermediaries, blockchain distributes trust across the network. This shift from trusted third parties to trustless systems represents one of blockchain's most revolutionary aspects. By building trust directly into the protocol, blockchain eliminates the need for trusted intermediaries while maintaining security and reliability. Consensus mechanisms are the backbone of blockchain technology, ensuring that all nodes in the network agree on the validity of transactions. Consensus mechanisms ensure that all nodes in the blockchain network agree on which transactions are valid. This prevents double spending, maintains data integrity, and establishes a single source of truth. When a new transaction is initiated, it is broadcast to all nodes in the network. Before it can be added to the blockchain, it must be validated through a consensus process. In proof of work, miners compete to solve complex mathematical puzzles. The first miner to find a solution that meets the target difficulty earns the right to add the next block to the chain. This process requires substantial computational power and energy. In contrast, proof-of-stake selects validators based on the amount of cryptocurrency they hold and are willing to stake as collateral. This method is significantly more energy efficient and is used by networks like Ethereum 2.0. Different blockchain networks use different consensus mechanisms based on their specific needs. Each has its own balance of security, energy efficiency, and scalability. One of the key problems solved by consensus mechanisms is double spending. If someone tries to spend the same cryptocurrency tokens twice by sending them to different recipients, the consensus mechanism will only validate the first transaction and reject the duplicate. Decentralization is a key feature that sets blockchain apart from traditional systems. Let's compare a centralized system with blockchain's decentralized approach. In a centralized system, all participants connect through a single central authority. If this central node fails, the entire system breaks down. In blockchain's decentralized network, even if multiple nodes fail or are compromised, the system continues to function. Blockchain distributes identical copies of the ledger across thousands of computers worldwide. Each node maintains a complete copy of the blockchain. This redundancy ensures that no single point of failure exists. Even if multiple nodes fail or are compromised, the network continues to function because the valid ledger information exists on all other nodes. This resilience against attacks and technical failures is crucial to blockchain's unbreakable chain of trust. Decentralization prevents any single entity from controlling or manipulating the system, ensuring the integrity of blockchain's trust model. This decentralized architecture is what makes blockchain technology revolutionary in building systems of trust. Blockchain technology introduces unprecedented levels of transparency and auditability. Public blockchains allow anyone to view all transactions ever conducted on the network. This radical transparency means that actions can be verified by any participant, creating accountability without requiring trust in individual actors. Every transaction leaves an indelible record that can be audited, providing proof that actions occurred exactly as claimed. This transparency is vital for applications requiring high levels of verification, such as supply chain management. Transparent blockchain systems also enable verifiable voting, where each vote can be counted and verified without revealing the voter's identity. Ultimately, blockchain transparency creates a system where accountability is built into the technology itself, rather than relying on trusted intermediaries. With these transparent and auditable features, blockchain establishes a new paradigm of verifiable trust. Smart contracts are self-executing programs stored on the blockchain. These digital agreements automatically enforce their terms when predetermined conditions are met. Let's compare traditional contracts with smart contracts to understand the differences. Traditional contracts require manual execution, intermediaries like lawyers or banks, and are subject to interpretation and disputes. Smart contracts, on the other hand, execute automatically when conditions are met, eliminate intermediaries, produce deterministic outcomes, and are immutable once deployed. Now, let's see how a smart contract actually works. Here's a simple escrow smart contract example. The buyer deposits funds into the contract, which holds them securely. Once the seller confirms delivery, the smart contract automatically verifies the condition. When all conditions are met, the contract automatically releases payment to the seller, with no need for a trusted third party. Smart contracts inherit the security properties of blockchain, making them extremely reliable. Smart contracts have three key security properties inherited from blockchain technology. First, they are immutable. Once deployed, the code cannot be altered, preventing unauthorized changes. Second, they are transparent. All participants can verify the contract code, enhancing trust. Third, they are deterministic. Smart contracts execute exactly as programmed, ensuring predictable outcomes. Smart contracts extend blockchain's chain of trust into automated processes and agreements, creating a new paradigm for digital interaction without intermediaries. As blockchain technology matures, its capacity to create trust continues to evolve. The blockchain ecosystem is expanding, with several key developments that are transforming how we establish trust in digital systems. Interoperability between different blockchains allows them to communicate and share information, creating a more connected ecosystem. Improved scalability solutions are addressing one of blockchain's biggest challenges: handling large transaction volumes efficiently. Enhanced privacy features are making blockchain suitable for sensitive applications while maintaining its transparency benefits. The integration of blockchain with other technologies like AI and IoT is creating new trust paradigms and expanding its potential applications. While challenges remain, blockchain's fundamental innovation represents a profound shift in how digital systems can operate securely in an increasingly connected world. Creating verifiable trust through technology rather than institutions is transforming how we establish trust in our digital interactions.